going?
Sure.
All right, let's do it. Welcome, everybody. Welcome to Virtual DrupalCon 2021, and thanks for coming to the session. We are here today to talk about Drupal and Roku and extending public television's reach. Quick note on the agenda: we're gonna, go through introductions, as is pretty normal. Set the landscape a little bit about why this project was undertaken. Talk about the role that Drupal plays and the integrations that we've done to bring this thing to reality. Share a little bit about the business impact, and then open the floor to questions. So to start, Kevin, why don't you introduce yourself?
How you doing? I'm Kevin Colligan. I oversee product and programming for KCTS9, which is the Seattle public PBS station. And we also have a news site, Crosscut, which is a nonprofit news site. Been a long time Drupal person since some time with the Grammys about 7 years ago.
Awesome. Chris?
I'm Chris Wills. I'm the manager of digital product and technology at KCTS9. I handle a lot of the planning and building of our kcts9.org, crosscut.com, and other Drupal-based sites.
Thank you. And I'm Frank Fabrero. I'm the CTO and a co-founder at Phase 2. Long been involved in the Drupal community and open source in general, and worked with our team over here at KCTS9 to do this project. So let's get underway. Kevin, you want to take it?
Yeah, sure. So the first thing I want to talk a little bit about is why we did this. KCTS9 is a television station based in Seattle, and we've got a big audience in Seattle and Vancouver, north of the border, as well as reach throughout Canada. But there's a reason why you see these streaming services cropping up like mushrooms all over. It's because television viewers are shifting to digital. If you want to go to the next slide there. So our television landscape is changing, and this is even before the pandemic that sort of really turbocharged streaming. So you see the top line there, pay TV households is on a steady decline, while non-pay TV households, people that don't have cable, is on a steady upswing, and they're expected to cross paths in 2024. As I say, this is before the pandemic, so I think this is probably accelerated a little bit. And then on the next slide, this was particularly an issue for KCTS9. So we projected out our viewership, and we saw a steady decline, right? So if you just look at the numbers here, we're going down from about 8.5 million, a little shy of that, in fiscal year 19. A pretty big drop down to under, losing more than 1 million viewers. 1 million households. And so really this becomes sort of an existential threat where a television audiences are moving to digital. Can we meet them there? Next slide, please. So the good thing is that we had sort of planned for this. When we built our Drupal 8 website, we knew it would be more than a website. We wanted it to be certainly a video, kind of a video application website, so people could have a good video viewing experience on the web. But we know most people like to watch TV at home on their flat screens. So we put in the foundation for an OTT platform. And what we did is, if you want to go to the next slide there, Frank, was we designed Drupal to be the hub. Next slide. Okay, so KCTS9 is we're the local PBS station, and we rely on PBS for a lot of our backend for our on their APIs. So they have a video platform called Media Manager. We've got TV scheduling, and so on. So we pull that information into our Drupal layer. The thing is, we don't have a ton of metadata around this content. We don't have a ton of data points around which to personalize and really customize people's experience. So we add our own curation layer atop that. So, for example, when we pull down content from PBS, it has about 9 different genres. we went and added our own editorial genre layer where we have about 70 or so genres. We added something called Vibe, which is like an emotive category. So, we could categorize something as maybe a nail biter or quirky or lighthearted to try to help us build dynamic packages. And if you see on the screen here, this is like a little snippet of our homepage. You've all seen this before, Netflix, Hulu, etc., where you have these carousels, rows of content. We have some which are manually operated by editors, but we really only have one person who's doing the content updates on the website. So we had to be smart about it. So we built, we leaned heavily on Drupal's taxonomy. And so, as I mentioned, we had the vibe and the genres that we added. And then when we build these carousels, it's actually a little bit on the left there, it's an image of our content management system. We make it so you could sort of mix and match. You can include genres and exclude. So one of the example that we use a lot is this here, modern mysteries. We said, give us all the content that's tagged with mystery, exclude anything that's a period piece. So we wouldn't get the older Perot's or what have you. And that worked pretty well. And it's, it's not personalized, but it's lets us organize content kind of at scale with a low lift. Next slide, please. And then what we did was we built an API atop Drupal. So there's some that we if you were to look at our homepage, you see we curate both our hero, so the top program that we're or the top several programs that we're offering to viewers, as well as different carousels, and everything takes place in the Drupal CMS. So we try to reuse things as much as possible. So all the carousels that are on our homepage are also fed up to the Roku app. Also, the hero slots, we control those separately, and we have different lineups for Canada and the US because we have different rights. And we feed all that content up, and basically, so we have that curation layer. But on top of that, and we'll get into that in a moment, we called in phase 2 to help us build the API, and then the clients on the OTT side as well. So a big piece of that was also putting in a recommendation engine. So Frank will get into that in just a moment, but now that our sort of signals and our source for Roku is basically our Drupal installation that has all the contents, all the metadata, all the editorial curation, and then we tie in the recommendation engine as well. And I can hand over to Frank maybe to talk a little bit about that.
Good lead in, thanks. So this diagram represents, kind of the ecosystem of the digital content delivery that we're talking about here, where Drupal is the main content repository for show and schedule information, and it ingests data from those various national PBS organization API. And within Drupal, it's curated and enhanced, and that content then powers the customer experience. So the users then interact with KCTS9 content either through the web platform, again, powered by Drupal, or through a Roku channel, which is published in the US and Canadian channel stores. The Roku channel then pulls its content from a content services API that is built on the serverless framework, which is published to AWS Lambda and API Gateway. And this API pulls the majority of its content catalog from the JSON API of Drupal, and it augments that data with a variety of personalized content that is stored and queried out of a graph database that powers the recommendation and personalization engine. So this architecture was built in a future-focused way that will expand easily to support other mobile and OTT platforms in the future. And now let's dive a bit deeper and learn more about how Drupal and serverless power the ecosystem. Chris, you want to take it?
So I'm just going to give a bit of a high-level overview of kind of the technology we use to put this all together. Frank, you just want to skip into the next slide there. The key to all of the data here is JSON API, which is kind of a lovely thing because it's a piece of Drupal core. I remember starting this project early on with phase 2, we kind of switched on JSON API, and that took care of like 75% of what we had to do. which was really great. So we got JSON API going in core. We grabbed a couple of extra contrib modules to help with that. JSON API extras is a really strong one for configuring, having a bit more configuration over the endpoints that core JSON API provides. So that allowed us to turn off endpoints we didn't need and turn off fields we didn't need and things like that. And then JSON API search is a integration for Solr. We use Solr search with our Acquia hosting. That allowed us to query the index directly via JSON API so that we could get our regular video and show searching into Roku. And then the last one, JSON API image styles, just gives us the ability to also send down various image styles with the pieces of content. And that allows us to fit specific sizes and image styles on Roku where we need them. And then one really nice thing with the JSON API is the field filtering that works out of the box. Kevin alluded to the fact that we deal with two audiences, the US and Canadian audience, and we have rights differences for content between those two audiences. And one thing that's really nice is with the JSON API, we essentially can just say a Boolean filter to say, if this is a Canada rights, send it down. If it's US rights, send it down. So it's very easy to filter out content that we don't have rights for to particular users in the US or Canada. And then the couple of things that JSON API didn't do for us where we did some custom work is authorization. In theory, JSON API could do this, but we have this kind of key requirement of doing geolocation in order to make sure that we're serving a specific area in Seattle, generally in the Seattle area, due to our agreements with PBS. So we had some special requirements there, and we were able to reuse existing functionality that we use on the website to send that down to Roku so that we can also make the same decisions there. And the other piece of custom work here is the screens, where we're able to build out the setup of the screen using paragraphs. So that's how we kind of build the flow for a screen, and then entity queues for pushing content to those various parts of the screens. And one thing that's just really nice is that the same node that powers the kcts9.org homepage also powers the Roku home screen. So all the content that we configure and manage and set up on kcts9.org also goes right down to Roku, so we don't have to manage two different things. And it allows us to have a really powerful system for our limited resources for editorial work on kcts9.org. So on the next slide, Frank. So the other piece of this is serverless. So this is kind of our in-between layer, what we call the Content Services API. And this is where we bring in that JSON API data for our shows and videos. And then we do a little bit of work on it to kind of smooth it out and make it standardized for Roku and any other platforms we'll add. The nice thing about using serverless is that we're able to stay in JS using Node.js, which is something we're familiar with here because we are also light on developers. We only have two developers here, myself and a front-end developer. So this allows us to do most of the heavy lifting in JS instead of trying to do a lot of that on the Roku side with its specific language and templating system and all that. So serverless allowed us to get set up very quickly with that. It uses Node.js and Webpack to build out these Lambda-ready handlers, and then it can deploy them directly to Lambda and put them behind the API gateway. The really nice thing about this is it's essentially one serverless.yml file that allows us to do all this configuring. So that file has all of the endpoints, all of the cache keys, all the supported methods for those endpoints. Everything goes in there, and we can run a simple CLI command to deploy that out, and that builds out all of our services on AWS with the Lambda and API gateway. Again, pretty much everything happens from the CLI. I've spent a little bit of time in AWS console, but it seems like just a terrible thing to be in. So I'm much happier to be doing things from the CLI, and serverless does that very, very well. One nice thing with this testing that we kind of miss in our other products, we use Postman and Newman here to very easily set up a test suite directly in Postman. If you're not familiar with Postman, it's a UI for building out API calls essentially. So we can build them out in a UI very easily, then we can export that into our repository, and then Newman will run those tests for us both in CI and locally as we need to. And that has come in really, really handy in this case where this was kind of a big project for us to bring on and add to what we were doing. And it gives me a lot more confidence when I do deploys that that tests run and tests pass and everything goes through CI. That's an area where we're kind of lacking in our other products, and it's definitely a nice feature of what we built out here with serverless and just kind of comes with what we did. I think that is all I have to say about how we have things set up. Here goes my timer. So Frank, I think I'm sending it back to you for a little bit about Neo4j and personalization.
Yep, let's talk a little bit about personalization, and then we'll touch on some of the front end stuff. So graph database. So we chose to use a graph database for a variety of reasons. When looking to build out personalization, we looked at tools like AWS Personalize and other similar technologies that you could build recommendation engines with. But we realized that we also needed to store data for capturing things like device activations, viewing histories, favorites, and other such information. And through our research, we realized that we could get kind of the best of both worlds with a graph database. It's a technology that's versatile enough to power a data store, but you can also run pretty sophisticated recommendation algorithms across the very same data. The other solutions we were looking at, we would have been required to export data into a more from a more traditional store into a format that was more fit for a machine learning algorithm. So of those graph databases we looked at, we decided on Neo4j. And a big part of that decision was its support for the Cypher query language, which is really powerful and it's easy to use. And it's basically the main supporting technology that powers the recommendation algorithm that we're going to talk about. Neo4j, like we said, it also powers all of the storage of our serverless API for the OTT channels. So like I said, we're storing data ranging from device activations to when a user favorites a show, to tracking what videos they're watching, and there's even some show metadata in there to help with recommendations. And the graph database just allows us to tie all of that together easily when it comes to generating recommendations for personalized content. So when we say personalized recommendations, what are we talking about? On the main homepage, there's a "We think you'll like" section, and that's a generated recommendation list that's based on the user's recent viewing history. When you finish watching a show, there's also a recommended up next video, and that's going to show you either the next episode if you're watching an episodic show and there's a next episode up sequentially, or you'll be presented with a featured video from one of your top recommendations based on the personalization again. Also on the homepage, there's a continue watching section that prompts you to continue watching any unfinished episodes or continue watching a show that has another episode sequentially, or even a show that you've previously finished that has a brand new episode up. And then finally, the generated personalization recommendations are also used to sort a variety of listings so that the shows in those listings are ones that you're most likely to enjoy. And each night, using that aggregate viewing data that we collect, we materialize popularity rankings for shows, and we calculate trending shows as well based on how that popularity changes over time. And from that, we also generate some excludes on the most popular shows, since those really popular shows can not only skew the recommendations like they'd be recommended to everybody, but also they can create a lot of edges or relationships between the nodes in the graph database, which can lead to some performance problems when generating the recommendations. So as for that algorithm, let's take a look. So what you see here, so we used a fairly common algorithm to generate recommendations. We used what's called a KNN, or K nearest neighbor, classification algorithm that tells us which users are similar to the current user by using the watch history of all those other users compared to the watch history of the current user. So this is a visualization of some of the data that's stored in this graph database. So you can see our user is the orange circle, and that has a directed watched relationship to the red nodes, which represent individual videos. Those videos also have another directed belongs to relationship to the blue nodes, which are the shows. And each of those shows has a directed has relationship to the green and gray nodes, which represent those various genres or categories that Kevin had mentioned earlier. Okay, so this is kind of the next step. So this next visualization shows how the viewing history of a single user can be related through watched videos to the corresponding shows to then find other users who've watched the same shows. So in this diagram, we have a collection of users represented by the orange nodes that have all watched the same show. In this case, the show's Grantchester. So once we have those groupings of users that have watched some of the same shows, we can score each other user with what's called a Jacquard scoring or distance algorithm. And that basically produces the user similarity score that you're seeing on the right. So we then can take the top 25 nearest neighbors, which is the K value in our K nearest neighbor algorithm, and we apply their ranking score to the shows that they've watched. And then the final step is we pivot that data to sum up those similarity scores for each show across all of the users in the similar set, and we get a ranking of shows that the current user might like. And that collection of shows is the recommendation set that's used for the personalization recommendation shown here in the We Think You'll Like section. So we calculate that recommendation set on application launch, and it's used for the duration of that user session. And like we said earlier, the recommended content is not only used directly in carousels, but it's also used to personalize some of the more common carousels across the site, like related shows, by ordering those lists based on what the recommendation algorithm thinks the user may be most interested in. Okay, so next I just wanted to talk a little bit about Roku as a platform. So Roku was chosen as the first platform on KCTS9's quest for OTT world domination due to its broad market penetration, both in OTT devices, and it's seen kind of a meteoric rise in the smart TV market. That's probably owed in some part to the TV buying binge that the COVID lockdowns brought on all of us. But as far as smart TVs with Roku OS, they outsold all competitors in 2020. And the estimates now are that Roku OS has a 38% share of the US smart TV market and a 31% share of the Canadian smart TV market. So pretty sizable market share. Roku is a bit of an entirely different beast, though, in the OTT market. They have a proprietary platform which is optimized for their hardware. And as such, there can be a significant ramp up if you need to go, that you'll need to go through if you wanted like a custom branded experience for your channel. And let's start with BrightScript, which is the programming language for the platform. It's a bit of Python with maybe a little bit of Visual Basic mixed in with JavaScript. And it's not that hard to learn as a language itself, as all languages do pretty familiar things, but it has some peculiar quirks, especially around how it supports fetching data from an API off of the main UI thread. So it does this to maintain UI responsiveness during operations that could go sideways. So learning how to take advantage of what they call their task model and how to observe data requests so that you can update your screens can take a little bit of getting used to. Next up, we have Scene Graph, which is basically like the HTML equivalent of Roku channels. So it's an XML-based language, and it's used to tie BrightScript, the programming language, with the UI components. It comes with some basic component building blocks, and it allows you to define higher order components for interacting with data and with your user. And one of the most useful aspects of Scene Graph is that each component and screen can have properties that you can observe, and you could take advantage of observing those properties for cross-component communication and coordination. Now, development environments can be a little bit challenging, as for Roku, there is no emulator, so you need an actual device on your local network set up in development mode. So all of the development code deploys take place to that local Roku device, and you'll probably need a separate display in order to see the results. But there are software-based remote controls, and there is the capability to automate remote sequences, so you can automate some of the testing to make things easier. Getting the debug logs also means you have to telnet into your Roku device and stream the logs to the console. Thankfully, though, there are IDE plugins to help automate the build, deploy, and debug process, and we use the ones for VS Code, so it's not quite as onerous as it sounds. But it's also not exactly like what you might be used to with modern web development. And as a final note, there's a small but very active and robust community of folks working on improving the Roku developer experience. And they can be found on the Roku developers Slack and in the Roku community on GitHub. They're working actively on something called Brighter Script, which is a superset of the BrightScript language with support for things like namespaces and classes and template strings, and even things like null coalescing operators and such. So we used Brighter Script on this app, and it helped considerably. And they're also working on ROPM, which is a package and dependency manager for BrightScript. So now that we've covered the technology platform for the channel that was released last year, let's go back to Kevin to talk a little bit about how the channel is performing.
All right, thanks. And we're running short on time here, so I'll try to buzz through this quickly. But overall, we're very happy. So we launched in kind of late November of last year. We didn't really start a marketing push until the new year. And so far, we've got about 75,000 installs. Those are net installs. So a lot of times people will install, check it out, uninstall. So we're up to 75,000 net. I should have mentioned earlier that the way that our digital service works is we have a lot of free content available for people who are in our designated market area. After something airs on our channel, it's usually online available for streaming for a week or so. But then we have something called Passport, where if you become a member of the organization, a donor, we unlock the whole catalog for you. So you get a lot more content. So directly attributable to Roku since launch, we've had about 675 donations to this Passport product, which it works out to about $50,000 in annualized donation value. So we haven't quite paid it off, but we've made a down payment. We've had about 70,000 hours streamed, and the average since launch, and over the last week or so, we're averaging about 95 minutes per viewer, per visit. So doing pretty well there. And just anecdotally, we've heard a lot of good things from our members who are happy about the experience and being able to sort of watch the great PBS programming on their own terms. So we've been pretty happy with it. We'll be looking to potentially branch out to more platforms, but I'll get one little final plug in here, Frank, if you wouldn't mind going to the next slide. We are hiring a full stack developer. So we've got a very ambitious roadmap. We're looking to continue on our quest for public television OTT world domination. So if anyone's interested, reach out to me or to Chris Wells. We're about to advertise it pretty soon. So it's not quite up yet, but it will be soon.
Fantastic. Thanks, Kevin. So we're going to be taking a couple of questions in the Q&A section. And if we run out of time, we're happy to maybe jump over to the Phase 2 booth after this and answer some questions there. So one question that came up, a couple of questions. Is the channel itself written in BrightScript or SceneGraph? It is written with both. They kind of work together. Yeah, BrightScript is doing, all the heavy programming stuff, and then SceneGraph is kind of like the component library aspect of it. And the next question is it assumed that because someone watched a show that they also like the show? Not necessarily, although watching is a signal. If you watch many videos, that is a much stronger signal that you like the show. Not many people watch tons of episodes of shows they don't like. So we can take that into account in terms of if folks like things or not. Let's see, has Roku's analytics system gotten any better? It used to not so good. So yeah, the analytics system, we plug into Google Analytics through this. Roku still has its channel analytics that you can use through your channel admin. And then again, we capture kind of custom viewing metrics in our own data store in order to do things that are most impactful and most relatable to our users' experience. Next question, what did it take to figure out the recommendation engine? Did you follow some sort of guide for setting that up? Yeah, we did. There's a lot of information out there. Neo4j has some really great playgrounds for playing around with some really basic recommendation algorithms. And then so we took our influence from there to learn how to use the Cypher query language a bit better. And then, kind of applied our own smarts. We, looked at the data. We saw what was sending the recommendations kind of off track, and we tried to optimize for the things that were not noise but were really strong signals. And we had quite a few iterations of the algorithm to get to something that was pretty valuable. Kevin, did you have anything to add, or Chris?
No, I don't think so. Other than it's been a great experience. We've long envisioned sort of Drupal being able to power multiple applications, and really happy that to partner with Phase 2 and make that vision a reality. So, I've worked on a lot of big Drupal projects. This was actually one of the smoothest ones I've worked on. So, kudos to our partners and our staff for that.
Yeah, it was a great team. All right, everybody. Thanks for coming. We appreciate it. And like I said, I'll be over at the Phase 2 booth. Kevin and Chris, if you wanted to join, you could meet us over there, and we could answer any more questions if there are any. So thank you very much. Have a great day. Enjoy your DrupalCon.
Thanks all.